Hi, students. This is Mr. Kutzi here. We're going to be talking about 3.2 puzzle time and the quadratics and parabolas and what we're supposed to see out of that. So what we're going to do is we're going to look at these questions, and let's see if we can zoom them in. Yep, there we go. Okay, so what it is for these first ones, it wants us to compare the graph of the function to the graph f of x equals x squared. Okay, so first things, just a reminder, don't worry about the f of x notation, f of x, j of x, c of x, g of x. They're just names. So instead of calling everything y equals, which is the same thing, this is just y equals, they're giving them names like Frank, Joe, Charlie, and Jeff. Or George, I guess, with a G. So anyways, that's what it is. So all these are just y equals x squared. So first, we should know at this point that that's a parabola. That we should know. In case you don't know, you're like, oh, I totally forgot what that looks like. So what you want to do is open up another browser tab and go y equals x and then squared. Okay. So there's our parabola. So that's the parent function. That's what we call the parent function. Let's go back to this. Okay, so these ones are both related. That's the idea here. These are both related to the parent function. They're from the same family. That's why we call it a parent function. So what that means is because they're both x squared, they're both going to be parabolas. How is this going to change it? Well, let's go check. Got this whole thing. Let's just copy and paste it. And that one was on -5 at the end. Okay, so we got the original function and the parent function. Sorry, the parent function and the modified function. Oh, by the way, if you click on these, you can make it disappear or reappear. Neat little features for that. The other thing is the parent function is in blue, the other one's in green. Excuse me. So what are they looking for? Compare the graph of the function to this. So what they're looking for is don't just draw a picture. They want you to compare using words. So what we're looking for here is sort of the second graph, this function with the -5 is the same shape. They're both parabolas, but this one goes down to 0, -5. It got shifted down 5. Let's make sure we see that. It used to go through 0, 0, but now everything got moved down by 5 because of this -5. It subtracted 5 from all of our points. So everything got moved down by 5. All right, so that's how you would answer the first one. It looks the same, but got shifted down by 5. Okay, the idea then is you say, oh, okay, the number 2 looks very similar. If this one was down by 5 and this one has +4, maybe +4 is up by 5. Well, let's check. So for number 2, you can keep this one in here if you wanted to graph a new one. And then what you can do is just turn it off. And let's put the +4. And there we go. Our new function is up by 4. So for number 2, adding the +4 shifted all of our points up by 4. So the whole graph looks the same but got moved upwards. Okay, so you can totally use the calculator for answering these types of questions, but the idea is eventually you want to be making predictions without having to use the calculator. Eventually you want to know, oh yeah, -5, that's down 5. Oh, +4, that's up 4. Okay, now other things that can happen here. The negative in front. We should remember what a negative does, but let's say we don't. So let's turn this one off, paste it in, but let's put a negative. And you say, oh, okay, the negative turns this upside down, and then the -8. And it's got a -8. You're like, whoa, wait, what happened to the graph? Okay, well, what happened is it's pointing upside down, and it got shifted down. So -8, you can't even see it on our graph. So let's drag this. There it is. It's at -8. So your original function was x squared. Let's get rid of these. There we go. Original function was x squared. This one is upside down because of the negative and shifted down because of the -8, the -8 at the end. Okay, so that's how that one is shifted. Okay, so this number at the outside number shifts it up or down. This thing in front is responsible for whether it's up or down. Okay, now what about these? When we have a 6 or we have a 1/3, let's take a look at that. Let's get rid of this. Let's just play around with the general one. Original function again, paste it in there. But let's do 1 divided by 6. And let's drag this down again. Okay, so the blue ones are original. 1/6 to it means it got increased at 1/6 the speed. All right. So that's what's going on. It's 1/6 as high. Okay, or another way to see that is when this one used to be at 6, this one would be down here really close to 1. All right, so this one's at 6. If you went straight down that line, this is really pretty close to 1. So, well, anyways, the idea is this thing right here will affect the steepness or the steepness of the sides, or you can say whether it's skinny or wide. Lots of different ways to say it. So again, if 1/6 makes it skinny, 1/6 makes it wider, let's see what would make it skinny. So instead of 1/6, let's use 6. So here we got it. 6x squared is really skinny, x squared is a little bit bigger, and 1/6 is really wide. Okay, so that's sort of what we got going on here. You got the one that's too wide, one that's too skinny, and one that's in the middle is just right. Kind of like a Goldilocks situation. All right, so hopefully that explains how the other numbers change it. If it's still not very clear, I highly encourage you to start playing around with your own numbers. Plug in stuff. Be curious. Throw in parentheses. See what things happen. If you get something really weird happen, let me know. We can talk about it in class. All right, thanks for watching, and I hope this helps.